Hi, I'm Jeff Nelson with Buggo Systems. Today we're going to unpack an MDS 4200, Modular Drive System 4200. That is a modular drive with a linear weaver. So, get started. Obviously, it comes in a box. The first box has the drive and the various pieces. Then we also have a 4-foot rail and an 8-foot rail. Comes packed in foam. Paperwork. So this is what you actually received. There'll be serial numbers on it. Best idea is to keep it, put it in the supervisor's office, something like that. Next thing, modular drive system literature pack. Inside this is a CD. Now DVD, say my age. Modular drive system, information and parts manual. So this has all the parts that are on here. So if something breaks or you need to replace a part, that information is going to be here. It's a great thing to have around. And warranty card. Good idea to get that filled out the same day. Little bundle of stuff. First thing is this big piece of plate. What in the world's that thing? This is a plate that will mount on the face of the modular drive unit. It allows you to, what it does is seals off the connectors on the front of the drive unit when you're not using a weaver assembly. I'll show you that in a little bit. Toolkit. Oh, another piece of toolkit. I dropped it. Toolkit has a little tiny wrench. Don't lose that one. It's very important. It's what you use to adjust the wheels, the V drive wheels on the weaver arm. Have a Allen wrench kit. It has various sizes. Allens, you're probably going to use these first two most of the time, and it has a little straight bit screwdriver on it. And last, quick wrench. Quick wrench. Well, it has the fittings to connect the magnets onto your rail. This, a couple spare fuses in case you need a spare fuse. A connector for the contactor. We also have another thing in here I'm going to show you, but if you have to make your own contactor cable, that's what this would be used for. There. These are adjustable screws for a couple of the fittings, and we'll get to those in a second also. So for now, lay this out. Okay, there's that. Next, there's the contactor cable I was talking about. See, it's the same thing, only this has a big cable connected to it. This is what turns the arc on and off. This is what, the same as your trigger switch on your manual gun. This allows you to do it from the control module. We'll hook that up a little bit. Here's the main portion. This is the main drive unit. It's made up of the carriage. You can see the extruded carriage. You can see the wheels. You can see how they adjust to fit onto a rail. We'll do this a little more detail in a little bit. You can see this pinion. That's what engages the rack on the rail. I am moving. This is a clutch that allows it to move in and out, that will in turn allow it to engage and disengage from the rack that will be going through the center here once we get our rail set. How about that? Maybe that's okay. So carriage, drive unit. This portion in the middle here. That's the main, the drive unit. It has the drive motor and gearbox in it. It has all the various connections to connect the other things to it. So it's it's the main, it's the base, it's whatever it connects to. Has a electrical input module here on the back. Has a contactor output. That's what we'll connect. When I was talking about the contactor cable, it goes through here. The control module. This portion up here can be removed and changed for other applications. Again, it's a modular drive, so it is modular in design. This is for a Weaver case. And finally, the Weaver, linear Weaver module, has the arm and such in it. Sit there. What else is in the box? Input power plug. Goes right there. Has a little switch on it, a little plug that allows it to catch inside there. There it is. These are the magnets. These get connected to the rail. 6 of them in the kit. I won't make the wash me go them all up, but here's what they look like. Right there. Magnet. Bag of 5/16, 18 screws that go into the top of the magnet and go through the rail and connect the magnets to the rail. Linear Weaver arm. It passes through the arm in that fashion so that we can get the linear motion. We'll put that in a moment. Finally, the vertical racking group. Again, I use the term vertical. That's with respect to whatever you're welding upon. It allows the gun to adjust up and down. Okay, so next thing is to open up a rail and start putting magnets on. And now we're going to put some magnets on our rail. When you are setting up a piece of rail, you don't have to position the magnets every other position. For our application here, given what we have to attach to, we're going to put 4 magnets, 1, 2, 3, 4, so that it fits like this. If your particular application allows you to put magnets at all ends, if you're working down on a flat table, of course, you'd space them evenly. If you have a space in between that you need to bridge, you could put 2 magnets here, a space, and 2 magnets here. There's no rule that says they have to be at a particular location. The rule is make it as stable as possible for your given application. You're allowed to decide where they're going to be. So very simply, obviously, 5/16 bolt goes into a tapped hole, pass through the rail itself. Find the hole, put one, put the other. Using the quick wrench, knock it down. There we go, there's one. Back in a second after I have all 4 of them on. Okay, so we've got our 4 magnets on our 8-foot rail. Again, we put them together because that's the area we have available to attach to. Again, if there was some way to attach down here, I'd put another magnet down there. But what I have is what's going to happen. So, I now line it up. In this particular case, I'm going to use this edge. is that edge. You can see there's nothing to turn the magnets on, just a twist. Twist, twist, twist. I can pull it off, but it didn't go easy. So you can see, pretty sturdy. Now, the drive. First, I'm going to move this out of my way. Oh, I forgot to mention, there's also this little doodad here. This is a Con 1020. It's a swivel adapter. This is a Bug 2708. In this case, it's used as a cable anchor. It's used to hold our cables so that they don't all connect just out at the gut. Also, the main drive assembly comes with a handle, and that's exactly what it's for. It's a handle, and it also acts as a cable anchor. So now, we're going to put the tractor on the ramp. The easiest way to do this, particularly in the vertical, hook the rigid side. So again, we have one side that's rigid, one side that's adjustable. Okay, can we see that? See, I turn this wheel and this all slides back and forth. The same with the pinion. I showed that before, but very important. Okay, so now hook this into one side. We rotate around and drive the star wheel until the wheels start to engage. Yes, it's a little twisty and it takes a little practice. Here's another. Here's one of Herb's hints. Once it's hanging here and you have one side on, if you set it at an angle, the top wheel on one side will be connected and the other diagonal wheel will be connected. Now, it will drive itself into place. When we turn the wheel, there we are. Now we take the clutch, turn that wheel until the pinion engages the gear rack. We're hanging on the wall. Earlier, we brought up this little wrench. This little wrench, in here, we can see a little V-wheel. That V-wheel is what this V-shaped hardened way fits into. I'm sure that the camera can't pick this up. It goes like that. But if there were a case, after it's been used a while, everything loosens up a little bit. This wrench, we take this cover off, and on top of there is a 7/16 bolt. And the wheel is on an eccentric. And it will allow us to tighten up this. After we've used it, a lot of times I'll go into the field and I'll hear, well, that thing's all loose. It's wiggling all over the place. And I'll look inside and no one has ever adjusted the V-wheels. And I'll say, where is the little 7/16 wrench that came with it? And the first answer is, we threw that away. Keep that. If you want, drill a hole in it, put it on your key ring, whatever. Now, and that allows us to adjust right there. So, this allows us to adjust the pinion on the motor. There's a motor that lays in here, flat. Similar to the motor that's on this case. This allows us to engage and disengage that pinion into the gear rack that's on the back of this linear arm. To insert this, we make sure that the gear rack is facing toward the rigid rail, or whatever rail. It's facing down towards the carriage. On this arm, depending on our environment that we need to weld in, here in this case, I've set up our example joint to the right-hand side of the rail. If, however, just because of the environment you're welding in, your joint is on this side, this piece right here, this 7/8 rod, you take these two screws out, you can pull it out, turn it, and put it in this end. Put two screws back in. That way, you can weld either left or the right, either right or the left. Now we're going to insert this, again, these two edges into the V-wheels. I've got to get in front of things so you can see. You can see it slides in. Now I'm going to go to the other end. I want to make sure that these V-wheels engage the V on the sides. Now we're moving back and forth. There's nothing engaged. We can adjust it as we like. Now, we engage this clutch. And now, we have the linear weaver arm connected. Next portion is this assembly. I told you about those adjustable bolts. Here's where I put the bolts in place. Take out this 1/4-20, well, what is that, 1.25 inch? And instead, you install this. I'm going to do it the same thing on the other side. Here's the use for the hex key kit. I'm going to break this loose. Take this one out. Now, if you're very certain of the position of this with respect to your workpiece, it's always going to be the same, then it's fine. Just use the regular bolt and get your hex key kit out and tighten them up. If, however, you take this machine and maybe today I'm doing vertical ups, tomorrow I'm setting it down and doing a horizontal stringers, I may have to change the position of this often. If that is the case, that's where these become handy. Thread these in. And now I can make an adjustment to this very quickly. I don't have to grab a hex key kit to deal with this little 1/4-20 socket here. It depends on the application. There's no rule. It's just what you like to do. Now, the other one goes in the opposite side. There you have it. Now, my habit is to place this to the outside so that I can get to it when I'm working on something. If I set it up this way, do this inside, and now what happens if, just because of the environment I'm working in, I need to do that? Well, now I don't have as much room on my machine. If, however, I set it up this way, I can bring it way back in here as far as the two bolt heads will allow me. Okay? Just another piece of information. So, we take the vertical racking arm, goes in place. This next piece, UNI 1036, goes on the outside, slides up and down. Now, here again, the handle is to the inside. Now, would that be convenient if I know I need to change my stick out while I'm welding, I'm under my hood, I'm going to have to reach in between to get that. What if I'm out this way? Now, I can reach around, I still have the view of what I'm working on, and I can reach around, and what if I'm welding from this side? Again, it's right in front of me, okay? Think about that as you're doing your setup. Here's your Content 20 and your 2708. You get basically two of those. One of them is used for holding the gun, one's holding the K1. Another case, let's try to put this handle out where we can get to it. All right? The second here, we're going to put a welding gun on it. And we're going to say, well, maybe that's not the right position. We'll know when we get there. We'll tighten that down. So now, and the other advantage, we disengage that, and we can turn that handle. Now it's out of the way. Same with our locking handle, our UNI 1036. Tighten that down, loosen it up. We disengage it and turn it so it's out of the way. Same thing back here. Okay, generally, weaver arms in place. Bug 5462 right angle clamps in place. Vertical machine racks in place. Uni 1036, Con 1020, Bug 2708. We have all the pieces to hold a welding gun in place. Just happen to have a welding gun. As we do this, think about how the cables are going to travel from our tractor to our welding machine. In this particular case, I'm going to set the gun up in this attitude so that the cable has a nice smooth move. We could, absolutely, wouldn't be any reason we couldn't just grab this and put it right in here, like this. Just a second here, I can turn this, grab it, there you go. I'm grab that, okay, there you go. But, what if someone comes by and wants to watch your weld and he's not paying attention, he stands on this cable? It'll happen. Because we're traveling up, and now we're putting tension and tension and tension, and now our gun is moving. Instead, let's try to do that, and we'll put a cable anchor over here to hold it in place. So, this is going to be boring for a minute while I move this around. Again, notice, this is I know it's a trade name, Legos, Erector set, Lincoln Logs, whatever. This is just a kit to assemble to do what you want to do. There's no absolute positive right way to do this. The other thing to keep in mind, every welding gun, almost every welding gun, has a little bit of a different shape to it. So, as we make adjustments and we fit things, now maybe that isn't going to be the best case, right? That is why, many times, I will strongly recommend that a straight barrel welding gun be used with this kind of product. Okay, now you can see the angle that I'm dealing with. We have to change all this. Here's one of Herb's hints. Given a straight barrel torch, now granted it doesn't have the front end parts on it. It's just what I had laying here in the shop. But you can imagine how easy it is to set this torch up. Nice straight line, no problem. I'm done already. Clamp it, I'm done, I'm ready to go. However, look at the variation, all the twisting, all the adjustment I have to make with this gun. I can see that right now I'm not where I need to be. I need to break this out. I need more reach. Put that down there. Put that out like that. Another piece of information is we know that the travel angle, push and drag, is very important to what a bead's going to look like. With this, I can't really get a good eye on what my travel angle is going to be because of the curving neck and everything. If we use our straight barrel torch, it's very easy to see our push and drag angle. So there we're generally in position. Let's see, stay there. Good. Now, good. Contact 1. 27.8. There's the gaze up. What goes through here? Obviously, our welding gun. Next, our input power. Now here's another little trick. We could certainly do this and hook it through there, and we plug it in. But what happens if we put this plug below this joint? The tractor's going to run up the wall and unplug itself. Again, if this got caught in the floor? If, however, we bundle this, pass this through the cable anchor, and plug it in above the cable anchor, we can still use that cable anchor for this extra cable. Put it all together, shove it in there, and we plug this together here. Now, as it travels up the wall or along the wall or whatever, and if something holds onto this, it's not going to unplug because the connection's above it. Next item, the MDS 1085. This is what we need to get the signal from the contactor the contactor switch on the drive unit back to the power source. This unit is plugged, connects here on the back side. I'm going to pull it up in the air. See? Here, ethanol plug, keyed, ready to go. Put it down. Yeah, cable, do the cable anchor. All of these cables, do the cable anchor. Okay. Turn it down. Now, we have used the cable anchor to do just that. It is anchoring all our cables. None of the connections, we can't unplug this. That's plugged in and now attached. We're not putting stress on the connection here. We're not putting stress on our welding gun, because all our stress is clear over here in the cable anchor. Now, we're almost to where we can start working on an arc. This is what the end of an MDS 1085 looks like. You have a white and black spade terminal. You have a red and brown spade terminal. There aren't very many wire feeders out there that I can plug that directly into. This is a common problem. So here's another of Herb's hints. Mr. Distributor, have these items available for your customers. This is the adapter that allows this cable to connect to a wire feeder. In this particular case, the two I have in my hand, this one is for a Lincoln. A lot of your hand welding guns that you're all familiar with, it'll have this coming out of the back of the gun, right? And it looks like this. But since we're not using the trigger switches in the welding gun, we're using this trigger switch, we need some way to connect to our wire feeder. These two items, having these available, will make your life so much easier. Again, Lincoln, Miller. In this particular case, I'm connecting to a Miller-Matic 255. So I'm going to use the Miller connector. Another Herb's hints. Tie it in a knot. This in front of the connection. Okay? A little square knot. So again, if somebody pulls on it, it doesn't just accidentally come unplugged. Now, these spade terminals In this particular case, since I only have one gun, the modular drive in other applications can run multiple guns. In this particular case, we're only running one gun, so we only need to turn on and off one gun. The white and black spade terminals are connected for one gun. All it is a dry contact. There's no electricity that flows over those. All it is a dry contact in and of itself. So these just plug into the front of there, very simply. And there we have it. But that way it doesn't come undone. Now, depending on your wire feeder, again, in this case, I'm connecting to a Miller mount. If you're connecting to a Miller 70 series, the plug's on the front. If you're connecting to a LN25, the plug's on the front. If you're talking about a suitcase 12, again, you know where all those plugs are. You deal with that regularly. I'm going to have to get behind here to plug this into the Miller. So now we're connected. Everything's together. Let's turn it on. Lights come on. Steering. Yep. Turn that control on. We're moving. Main on-off switch is back here. Goes in right beside where the power cable connects. Right back here. This turns the functionality of the machine on and off. This provides the different weave patterns. This turns your welding gun on and off. This is the same as your trigger switch if you're running a manual welding process and you pull the trigger. This is the same situation. Here's another Herb's hints. With the contactor switch on any Buggo equipment, your wire feeder needs to be in 2-step, not 4-step. In 4-step, we pull the trigger, we let go of the trigger, the arc stays on. When we want to when we want to finish welding, we pull the trigger again and let go. It turns the arc off. That doesn't work in our case. What we need is in 2-step. We pull the trigger, and as long as we hold the trigger, the arc continues. When we let go of the trigger, the arc turns off. That's how this switch works on all Buggo equipment. When you turn it on, the arc is on. When you turn it off, the arc turns off, as long as the wire feeder is set in 2-step. 2-step, 4-step, critical to making it work and not being frustrated with the machine. Other items: forward, off, reverse. We'll come back to the weave location. Travel speed. You can see the LED, and as we turn it, it increases. As we counterclockwise, decreases. These two knobs are for dwell time. Let's turn the dwell on. There, we can see the weaver moving back and forth. Now, there's no dwell. When it gets to the end, it turns right back. Now, let's turn this number way up. You can see that it stopped on that side. Stop. Now, if we set the same on this side, you can see it blowing on each side. Slow those down, turn those down. Now, other two knobs. Speed. This is oscillation speed. As I turn that up, see how fast it goes back and forth. I'll turn the dwells down so we can see it even better. Finally, weave width. Again, the bigger the number, the wider the weave. Little tiny dig. There, that's more like what we might want to see, right? But maybe we need a wide weave, we're overlaying, or maybe we're going to cap. Wide oscillation, a little faster. And finally, this is steering. It allows us to reposition. So I'm turning to the right and look at the arm go to the right. But the weave width is always the same. This knob only changes the position of the center of oscillation. It does not change the width of oscillation. Now, last thing to remember about setup. We want to put the gun about in the center of where we're going to weld. So, first thing to do that, we release this clutch completely, all the way. This arm can move in and of itself. Now, we set this knob to its center of motion. This has a 3-turn pot. We'll turn all the way to one side. We've turned all the way clockwise. Now, we'll turn 1.5 turns counterclockwise. 1.5. There's a little white mark on here that you can see. Now, the motor and the encoder, the counter, are centered. Now, we want to put the gun centered over where we want to work. So, need to do a little bit. Let's do this. Now, do that. Okay. Now, we center that over top of where we want to work. Now, we close the clutch, engage the pinion. Now, I can steer to either side, and I'll have equal travel to either side of the weld joint. Position, steer, turn, leave. There you go. One of the things I brought up earlier was this plate. We took it out of the box. What in the world's that plate for? If we had an application where we were just going to use the drive assembly, maybe we're just using it as a cutting machine. Maybe we're just beveling plates. Or maybe we just have a straight weld that we have no need to use a weaver. We just need a straight line tractor. If we remove this weaver assembly, there are 2 connectors that pass both power and information between the drive unit and the weaver module. What this plate does, it mounts in place of this drive unit, right there, but on the face, to protect those connectors. You can see it has a little recess in there for the connectors to fit into. And it mounts. It can also be, once you have that on there, you can also mount a racking group on the side of it to hold a cutting torch or a welding torch, welding gun. So, review. We've taken a modular drive, MDS 4200. That is a modular drive with a linear weaver. We have described all the various parts, the drive unit, the control module, the weaver module, the carriage, the magnets that come with it, the ARR 1080 aluminum rigid rail. We've described each one of the various parts in the box. We have connected it electrically. We've connected it to the wire feeder via the MDS 1085 contactor. We've brought up the need for an adapter that will connect the MDS 1085 to the wire feeder. We've put a gun into place. We've adjusted the position side to side. The next thing to do will be to light up. So, next time, we're going to discuss what each one of these various travel modes will do and advantages and disadvantages when using the modular drive system. Thank you.